Here, first question, consider first question. A is the wave pulse, B is the support. Here A, B thickness greater than A, velocity of A greater than B. Why? B, that is the equation. B is equal to root of T over M. That is the transverse wave equation already given. Here in this equation, B inversely proportional to root A. That means if cross section area increases, velocity decreases. Here B, the small velocity than A higher velocity. Here B is the rigid support, two supports. Here B thickness larger than this one, so B is the rigid support. So rigid support means the waves inverted. Here pulse in this direction, after the reflection is inverted. But here transmitted wave no change, it's moving in this direction. But in this situation, here the amplitude, this both amplitude lesser than this amplitude. Okay, that is the first question. Second question, here is a wave pulse two pulses moving towards two different, denoted by two different colors. Here red color and the purple color. So after some instant, it's moving right with the same size, also same dimension. Here also moving left with the same dimension, not alter. So it must not change the shape. So that is the answer. I think that is the first answer, right? Then consider third question. Here the waves, that is a purple color waves, means the waves moving right in this direction, right? So our question, find the AB after some interval, find the direction of the AB particle, that is the transverse wave. So we have to find the AB position. We have to draw the another waveform. That is the red color is the another waveform after some interval. First instant the wave, that's purple color wave. After some interval, small interval, red color wave. So then draw the position. Position means the blue red color light up wave in this position. So A moving upward, similarly B moving downward. So from this the answer fourth, A begins to move upwards, B begins to move downward. That is the third question answer. Consider the fourth question. Right, fourth question. Here, which of the following waveform is the higher frequency? Higher frequency means smaller wavelength. Here this is the higher frequency, this is the lower frequency. Depends on frequency. To check the waveform, that's a higher frequency. That is the answer. I think fifth answer. Then fifth question. Here there is a question. So after they separate the two pulses separated by 8 centimeter, moving towards. So after some interval, what happened? What is the position? So here in this position here, after 2 seconds, consider by using relative velocity. Relative velocity means if it's rest, it's moving 4 centimeter square. So it's separated by 8 centimeter. After 2 seconds, it's moving 8 centimeter. 8 centimeter means like this. So that is a destructive interference. So the total waves are vanished. So that is the final waveform. That is the fifth answer. Sixth question. So that is here flexible support, wave moving this way. After reflection, it's moving that wave from here is a slant position, also slant. So there is a incident wave, that is a reflected wave like this. That is a second answer. Then I only consider except 6, 7, 8, 9 are easy questions. So consider this 10 question, right? 10. Here is going in the two waves pulse towards each other. It's two different pulses. It is superposition. Its amplitude double the identical wave pulses. double. Here after that, that is the position. Here this way, this pulse here, that pulse here. That is the answer. The oscilloscope, there is the oscilloscope diagram. Receive two waveforms. One waveform 50 hertz. So other in here another waveform. These two waves overlap. Say this one F1, another one F2. If two waves are overlap, the waveform like this. That is the beats. The beats frequency means if the two waves, one wave F1, another one F2, the beat frequency, if F1 greater than F2, wave beats frequency F1 minus F2. So F1 given, F1 say 50. So you have to find F2. The resultant waveform, there is a beat frequency, beat form here. From this you have to find the F2, other waveform. So how to find? So here check the waveform here in this two dots, 5 waves. Each wave frequency 50 hertz means each time period, wavelength or time period 1 by 50 seconds. So here 5 wave. So altogether totally here 1 by 10 second, that is here between the two dots 1 by 10 second. So this is the wave pulse frequency. How to find pulse frequency? Inverse of time period. So time period 1 by 10 seconds. So frequency, that's the beats frequency, is equal to 10 hertz. Okay, how to find? First check this time interval. This time interval means beats interval between two faint, here loud, two faint. Between two faint sound, interval means beats interval. The inverse of beats interval means beats frequency, 10 hertz. That means every 1 second we heard 10 sound, 10 high pitch sounds. Okay, then 15 question. Consider 15 question. Here a wave pulse moving, shown in the figure, moving straight towards the boundary, and it's a rigid support. Here rigid support. So question, find the waveform. Here I draw some another additional instance. Here if the wave, there is a purple color, right? Purple color wave, the wave format in this position. After here some position here vanishes. That vanishes point, waveform here inverted like this. So that is a resultant wave. So you draw the resultant wave here. The blue color means resultant wave. In this position, if the wave in this position, the resultant wave, blue color wave. Then after some interval, it's moving in this way. So here this wave vanishes. Here not shown here, but in this wave inverted here in this wave. So resultant wave, there is the same analytical form. So resultant wave 0. So here your answer, fifth answer. Check your question. Then the answer is the fifth answer. Okay.